Somewhere above your head right now, 40 years ago, something started to disappear. Not slowly, not quietly. A tear was opening in the sky itself, in the thin, invisible shield that has protected every living thing on this planet since life first crawled out of the ocean. By the time anyone noticed, it was already the size of a continent. Scientists ran the numbers forward. Within a few decades, they said, this shield could fail completely. Skin cancer rates would explode. Crops would wither under raw, unfiltered sunlight. Entire ecosystems, blind to what was coming, would simply collapse. And the cause was not a meteor, not a war, not some distant industrial accident. The cause was sitting quietly in your bathroom cabinet. This is the story of the ozone layer. How we nearly destroyed it without even knowing its name. How the entire world came together to save it. And why, quietly, in the years since, new dangers have started creeping back in. To understand what almost broke, you first have to understand what it actually does. Wrap your planet in a jacket, several jackets really, stacked one on top of another. The one closest to the ground is where you live, where weather happens, where every cloud you have ever seen was born. Climb higher, past where commercial jets cruise, and you enter a stranger world, a layer where, unlike down below, the air gets warmer the higher you go. That is not an accident. That warmth is a signature, the fingerprint of something quietly at work. That something is ozone. It is a strange molecule, just 3 oxygen atoms, bound together instead of the 2 you are breathing right now. Thin, pale, faintly sharp-smelling, it is the scent that lingers in the air right after a thunderstorm. And depending on where it sits, ozone is either a poison or a protector. Down at ground level, it is a pollutant, a component of smog, something that irritates lungs and damages plants. But stretched thin, in a layer high above the clouds, it becomes something else entirely. A planetary sunscreen, filtering out the overwhelming majority of the sun's most dangerous radiation before it ever reaches us. Without it, the surface of this planet would be effectively sterile. And here is the unsettling part. This shield is almost absurdly thin. If you could somehow gather every molecule of ozone in the sky and compress it down onto the surface of the Earth, it would form a layer only a few millimeters thick, thinner than a coin. That is all that stands between us and radiation, capable of shredding DNA itself. For most of the 20th century, nobody thought to worry about it. Ozone was simply there, a quiet, permanent fixture of the sky. Then, in the mid-1980s, a small team of researchers, working in one of the most isolated places on Earth, noticed something in their data that should not have been possible. Year after year, measurements taken above a frozen research station showed the ozone thinning, not by a little, but by roughly a third, in less than a decade. At first, other scientists refused to believe it. The instruments must be faulty, they said. Nobody builds a machine that measures a planetary catastrophe by accident, and surely nobody would miss one for years without noticing. The data must be wrong, they insisted. It was not. And there had in fact been a warning years earlier, a theory published back in the 1970s, and largely dismissed at the time, suggesting that a class of everyday chemicals could rise into the upper atmosphere and start tearing ozone apart. The scientists behind that idea were mocked, accused of scaremongering. Years later, they would win a Nobel Prize for being right all along. Those chemicals had a name, chlorofluorocarbons, or CFCs. You would have known them by what they did, rather than what they were called. They were the coolant, humming quietly inside every refrigerator. The propellant hissing out of every can of hairspray and deodorant. Odorless, invisible. Marketed at the time as one of the safest inventions of the modern age. Nobody meant any harm. That is what makes this story so uncomfortable. Here is what those seemingly safe molecules were actually doing, high above our heads. A CFC molecule is fragile in one very specific place, the bond holding a chlorine atom onto the rest of its structure. Down at ground level, that bond holds firm. But drift high enough into the stratosphere, and the sun's own ultraviolet light delivers just enough energy to snap it apart. That releases a single, furious chlorine atom. And chlorine, once freed, becomes something like a molecular wrecking ball. It slams into an ozone molecule, rips it apart, and walks away completely unharmed, ready to do it again and again and again. A single chlorine atom can go on to destroy well over 100,000 ozone molecules before it is finally neutralized. It is not really a hole up there, not in the way you might picture one. It is a region where the shield has been shredded down to almost nothing, mostly hovering above the frozen expanse of Antarctica. Extreme cold there traps swirling winds and forms icy high-altitude clouds that act almost like a chemical reaction chamber, priming the chlorine for a springtime feeding frenzy the moment sunlight finally returns. And here is the part that should genuinely unsettle you. These molecules do not break down quickly. Some varieties can linger in the atmosphere for over a century. Every hairspray can, every leaking refrigerator, every one of those seemingly harmless purchases from decades ago, some of that damage is still quietly being paid off today. So how do you stop a slow-motion catastrophe that is already baked into the sky? In 1987, something happened that has genuinely never happened again, before or since. Every single nation on Earth, every government, regardless of ideology, wealth, or rivalry, signed onto one agreement, a global commitment to phase out the chemicals destroying the ozone layer. It stands as the only environmental treaty in history to achieve total, universal ratification. And remarkably, it worked. Emissions of the worst offending chemicals have collapsed by close to 99%. And more than that, the shield itself has started to heal. Not merely stopped shrinking, but actually, measurably, regrowing. Scientists now project a near-full recovery within the coming decades, sometime around the middle of this century, depending on the region in question. It stands as one of the only moments in modern history when humanity looked directly at a planetary-scale threat and simply fixed it, not through some single miracle technology or last-minute invention, but through cooperation, through governments trusting scientists and trusting each other, enough to act before the worst of the damage had already been done. But this is not quite the fairy tale ending it is often sold as. Some of the chemicals that replaced CFCs turned out to carry their own hidden costs, some destroying ozone almost as effectively, others turning out to be powerful greenhouse gases in their own right, others breaking down into a class of pollutants that essentially never disappear at all. Illegal production has even been caught happening in recent years, quietly undermining decades of progress before investigators manage to trace the source and shut it down. Wildfires, now larger and more frequent as the climate continues to warm, can punch smoke and chemical particles directly into the stratosphere, chipping away at the very layer the world worked so hard to rebuild. And high overhead, an entirely new threat is quietly accumulating. Tens of thousands of satellites now circle this planet, with tens of thousands more planned before the decade is out. Most will not last long. When they burn up on re-entry, they scatter fine particles into the upper atmosphere, particles that, it turns out, chip away at ozone all over again. The shield we fought so hard to save is now being tested by threats nobody was even thinking about back in 1987. Nitrous oxide, largely tied to modern agriculture, has quietly become one of the largest remaining chemical threats to that same fragile layer. And unlike CFCs, it was never covered by the original agreement at all. So, did we actually fix it? Yes. Genuinely. Remarkably. Yes. But fixed does not mean forgotten. It means we bought ourselves decades of borrowed time, on the quiet condition that we keep paying attention. The ozone story stands as proof of something rare, that when the science is clear and the world chooses to listen, catastrophe is not inevitable. It becomes a choice we get to make, together, all at once. The uncomfortable question left hanging over all of it is whether we would still make that same choice today, if the same crisis unfolded right now, in front of us. I would like to believe that we would. I am honestly not sure, and that uncertainty alone feels worth sitting with.